Hi there, and welcome to a presentation from Stanswell. We're going to be talking about business experiments, and particularly in the context of revenue operations. It's been some time. Those of you who follow, 6 months ago or so, we started working on something called the Bowtie funnel. Unfortunately, client work has preoccupied us or me for some time now. So this is just finding a bit of time, evenings and weekends, to take that whole bit of thinking forward. So the background to this is we all hear discussion of things like value, actionable insights, and decision making around the whole uh, business performance management context and domain. And in particular, the work I've been doing recently has been in the revenue operations space. So let's drill down on that and see if we can come to some actionable, practical insights about implementing this kind of model. So the people who probably lead the thinking, excuse me, on revenue operations within the standard CRM space are HubSpot. They talk about it not being a linear process, but actually being a cycle, a flywheel, that there are forces that will increase the speed of the flywheel, but equally there are forces that will reduce it, cause friction. But they still talk about using funnels to understand how customers go through different states. So they haven't replaced the funnel with a flywheel. It's a complementary thing. And they talk about understanding the business model. And there are other people who take that further into something called the bow tie funnel, which is an idea of not just taking customers through a journey of lead to opportunity to sale, but thereafter managing them actively within the customer base and encouraging, with renewals and upsells and trying to avoid churn and all of those good things, and also using those customers to encourage other customers, inviting them to events, because of course these loyal and sticky customers are hopefully the people who can advertise your product the best. So what approach are we going to take to this? First of all, you need a good idea. And there's mention there of a data model, a process model. You need to have an idea of what a valuable set of activities are. Now, you can take one of those ideas off the shelf, RevOps, as I said, product-led growth, which I think is a kind of a flavor of RevOps, which is using the product to sell itself. It's particularly true in, I think, software as a service, the idea that people can adopt your product easily and move up the customer journey easily, etc. So an interesting flavor. But if you're going to just take these off the shelf, I would encourage you to have an understanding of business performance management and measurement techniques. There's an absolutely foundational book edited by a guy called Andrew Neely that covers a whole range of thinking on business performance measurement. And I think that would be a foundational set of knowledge that anyone who wants to design these systems should avail themselves of, rather than just go to an off-the-shelf idea of RevOps. I think there's a more fundamental set of principles that you should be adopting. At the very least, I would encourage you to go through some kind of terminology taxonomy discussions, not a technology-driven one like a data model, but a business terminology. Understand the terms that you use need to be disambiguated in order to be implemented in a system. If you're using the name of a metric, then that metric needs to be defined. Something like churn, something like active customers. These are things that they're easy to say, but unfortunately, when it comes to implementing them as a system, it highlights subtle differences in understanding and lack of clarity about definitions. So I would encourage you, as a kind of foundational activity, to go through some kind of business glossary thinking. Right, you'll need a database. That could be Dynamics or Salesforce or HubSpot or something else, something to store your data. You'll need an analytics data platform of some kind, Power BI, Tableau, Google BigQuery, Databricks, or if you're going to go to the whole hog, Databricks certainly. Microsoft Fabric is an end-to-end data and analytics platform that is becoming, Microsoft's first-class product in this area. You need some thinking, some foundational uh, methodologies and understandings of social science practice. So things like adaptive cognitive fit. Cognitive fit is a principle that's been around for 20 or 30 years. The idea that making decisions is easier if the data presented is conducive to those decisions. So a simple thing like a table versus a chart of growth. If you're given a table, you're going to have to do some calculation and mental imaging to understand whether the numbers are growing. But if you're shown a chart, you understand intuitively. That's been around for a long time, but it really only fits simple examples. We are, I think, presenting a much more sophisticated concept. And this is where adaptive cognitive fit comes in. The idea that AI can adapt what it is you see, that if you're asking a particular question, AI can model it and then represent the data in a particular way to help you make that decision. There's other things like, excuse me, task technology fit, which is matching the technology to the individual task, which is a crucial issue if you're going to be successful in any software implementation. But it also I think starts to get into the whole idea of knowledge intensive work. You've got typically you're not dealing with deterministic tasks. You're dealing with things that require nuanced decisions. So the idea of task technology fit in that knowledge intensive space is more problematic. I would encourage you to understand about things presenting information in certain ways, multimedia learning, and how we learn. These books and theories attack some of the myths about how we learn. The idea of learning styles of auditory and kinesthetic, etc., etc. All of these things I think are worth thinking about if you're in the business of trying to get actionable insights and present information that is cognitively fit to the intention, then these are principles that you should be aware of. You need some kind of framework. There's two kind of extremes of business experiment. One is at the high level, some kind of business model formulation and testing. The idea of if you've got a high level idea, how do you fail fast? If you've got something that ultimately would take lots of intensive technology processing, then can you mock it up in some kind of whiteboard session first in order to test whether people are going to buy it, because it would be a wasted investment to spend a lot of money on a product that ultimately they're not going to buy. So there's a business experiment thinking at that end. At the other end, the very kind of detailed book designing experiments and analyzing data, which starts actually with some very interesting chapters on the nature of science, the role of statistics within science, the role of statistical models, and then goes on to help you design experiments. It's not for the faint-hearted. It starts reasonably simply, but certainly it will have everything that we need to carry out very sophisticated data experiments. You'll need some data. You can either generate that with something like system dynamics or agent-based modeling, which I'll talk about, or use something like a Python faker just to generate data. This, I think, is very useful. One of the obstacles at the start of any technology implementation often is, of course, you have no data because you haven't got a system, you haven't started collecting the data. But I don't think that should be an obstacle to getting started with the end-to-end process. Reporting and analytics are often left to the end of a project. To me, they should actually be the start of a project. You should work out whether some kind of data representation can drive the valuable, actionable insights that you want. Test that first, and only when that is successful should you think about implementing and designing a system. So very much encourage you to do this kind of business data experiment process, and to make it part of your day-to-day operating model, experiment first type thinking, and put the tools together that you need in order to carry those experiments out. So that's true of tools. There's a thing called AutoML, which allows you to apply different models to a particular problem to find which model is best. There's causal inference, which is using data to understand the causal processes and causal flows within your behaviors. So sales, the idea of what is it that leads to a successful sales outcome, what interactions in what order, what encourages what, etc. This is not just regression analysis, which says that sales are positively correlated with this kind of activity. It's a much more sophisticated piece of work, and we'll come to that. And then finally, D3JS, which is a custom graphical visualization tool, which can be used to draw pretty much any picture that you want. One of the problems with the analytics tools is, of course, you're limited to out-of-the-box visualizations, which are fine for certain purposes, but if you're talking about really nuanced processes, then you might need to think again. All of this can be augmented with AI. So whether it's OpenAI, ChatGPT, Google, Microsoft Copilot, Meta, whatever your AI model of choice is, then all of this can be assisted with these tools. You can use it to read books, to compare books, to come up with data models, to challenge assumptions, to design experiments, to implementing data creation like fake or whatever, and you'll see some of that, right through to understanding the results and interpreting them. So I very much encourage you, if you're not already, to think AI first when you are wanting to challenge yourself to get to any business outcome. I certainly use it multiple times a day. Right, business data experiments. As I said, the business model navigator is a kind of business model canvas type approach of understanding the high level drivers of your business and then trying to experiment to test them. But the Maxwell, Delaney, and Kelly book, Designing Experiments, I very much recommend if you want to take this seriously. What are the stages? Define the business problem and formulate a hypothesis. Come up with something in your mind that you think will be valuable. If we increase the number of telephone calls, then we will increase sales. If we increase the quality of our collateral, we will increase sales. If we respond to a marketing inbound marketing activity within 30 minutes, within 60 minutes, within certain times at weekends, because people have time to respond to this kind of thing. There's all sorts of hypotheses that you could state in order to test and to discern whether they are valuable. You can do it at a high level, which is to say something like, overall, the RevOps function would add value. Or you could do it at a very low level, which the kind of binary if then else type thinking. Obviously, different approaches might be appropriate for the two, and you might have to then, if you take the high level approach, you can decompose it into certain assumptions, but it's certainly something that it fits all levels. Design the experiment and identify key metrics. This experimental design, what is it we need to do to test this hypothesis rather? What are the key metrics that we need to capture? You can generate, collect, or synthesize data. So you can generate it using AI. or the Faker model I'm going to show you, you can collect it by survey or some kind of activity, actual activity within the CRM system, or you can synthesize it using system dynamics or agent-based modeling. Perform exploratory data analysis. You can do this either visually yourself or put it through some kind of auto ML process to say, okay, now that we've captured the data, what kind of analysis does this data support? What kind of algorithms would be useful to see what the relationships are between the different variables in the data, and do they support the analysis of the hypothesis? You can then go into feature engineering and pre-processing, preparing it for the algorithmic approach, AutoML and model selection. AutoML is a way of firing multiple models at your data and saying which model explains the data best. So, there's all sorts of different algorithmic approaches, random forest, and the large language model, et cetera, et cetera. All of them are different types of algorithm. AutoML allows you to not have to do it manually one by one, but you can just feed the data into the various models, and then models can be compared. You can analyze the results and visualize the insights. We're going to show you some of that, and then conduct causal inference and counterfactual analysis. What drives what? What are the causal influences in this process, and what would have happened had we done something else? This is not just predictive analytics, which is predicting what's going to happen in the future. It's prescriptive analytics of saying what we should do about it and what would have happened otherwise. So there's a very sophisticated set of tools that are available. Finally, interpret the findings and drive business decisions. Why will we be doing this? Is it valuable? Can we intervene in a certain way? How would we know what the impact of that is? How efficient is our measurement system? And how are we learning? Okay, mentioned data modeling. System dynamics is a favorite of mine. The idea of creating models which represent your stocks and flows and how they interact. It's great for analyzing system behavior as a whole and the emergent behavior of systems, optimization challenges, etc. The one downside is it's not great at tracking individual agent activity. So it deals with stocks of stuff rather than identifying individual items within that stuff. So it's got its strengths and weaknesses. I mentioned agent-based modeling. This does identify individual agents and gives them behaviors and allows them to interact with each other. So in this case, it's individuals trying to get the best bid in a market or the best deal in a market, and negotiating. So you run these models and you get the behaviors. You can I couldn't find one that was specifically for sales, but you could create notional customers who are interacting with your product in a certain way based upon certain rules, and you could use that to simulate data. I mentioned Faker. This is a AI-driven development environment where all I've done is asked in plain English, can you use Python Faker to generate a set of data for the sales funnel? The stages in that funnel should be total addressable market, lead, opportunity, sale, install base, and churn. Do this in a new file. So it gives you the code, and then you can run the code, and you get the data. So you can go from plain English to synthesized data without having to wonder too much about how it works. If you want to add columns or add behaviors to the data, you could say, I would like my data to demonstrate the following behaviors, because what you're looking to do is test certain things, certain models, certain diagrams. You can ask the data to behave in a certain way, or you could randomize it. You could, ask for black swan type events, etc., etc., etc. Obviously you can interact with this plain English in any way that you want. You can also, and this is something in the absence of any other tools I would encourage, model your data in Excel. So think about how the data, rather than ask for the system to create the data, to get the data to then start reporting it, just go to Excel. Don't worry about data models and relational data, etc. Just come up with a simple table of what's called denormalized data, where you're just adding columns as you want to add information. So in this case, very simply, I've got 6 customers in 2 stages, leads and opportunities. That supports this kind of analysis. I can count leads and opportunities. If I were to add the month, so now we've got the prior month and the current month, and obviously the customer statuses in some cases have changed, then I can model that. I can say, leads, current, prior, opportunity, etc. So this is very simple data modeling and working out what that data model supports in terms of a visualization. And you can obviously extend that, budget and forecast and what have you. But you've got very good control over what the data says and what you can then visualize. Okay, so RevOps, revenue operations, tends to focus on funnels of or pipelines of activity, moving customers from one state to another through the customer journey. So you could start on the left-hand side with leads and opportunities and then sales. But, in trying to improve this thinking, always these methodologies always never stand still. They're always trying to say, oh, there's something new, there's something new, there's something new. So over a few years ago, the Bowtie funnel started to appear, which says that we're interested in customers after they've been onboarded. Now, I've put X and Y question mark because it's kind of arbitrary, whereas leads, opportunities, and sales seems to me to be pretty intuitive. It's kind of arbitrary what you would then do next. You might have onboarding status of customers, or the idea that some customers are new and unsure and uncertain and not necessarily loyal, but you move them through some life cycle of being loyal. So, on the right-hand side, you've got sticky customers. To me, the right-hand side seems a bit arbitrary because it doesn't necessarily behave like a bow tie. You might find that something sequentially to the right of X is smaller than X, who knows? But you get the point. There's also the possibility of adding exposure to your total addressable market if you wanted to start thinking about the interactions between that and leads. And then finally, churn on the right-hand side. Obviously, people can churn whereas at this stage you're losing people before sales, but once you've got them on board, they are churning. Okay, you could toggle between the number of customers and the value of the customers if you wanted. And also you could add classifications and segmenting of various things. So this could be by value. The one customer could make up 25% of your value, and 25% of your customers are small. Or you could use that to segment other things like likelihood of churn. You could say, of these customers, the following at the top are more likely to churn. So there's all sorts of things you could overlay over this kind of view. But we'll take that off for the moment. What I'm going to overlay is prior month. So here what we've got is, this is how the current month compares to the prior month. So in the case of leads, we did have whatever that is, you put a measure on it, but now we've got fewer. Here we've improved opportunities, we've reduced sales, etc. So that gives you some kind of view as to how you are performing month over month, period over period. Take that out. You could also add budget. So here we've got the budget and we've got conditional formatting. So the budget for the leads for this period was higher than we've delivered. Here we're doing better, here we're doing better, and we've churned more than we thought. So that's showing very intuitively how you're performing against budget. You could do the same against forecast. So this is simply the forecast, which again is represented just as a conditional formatting approach. You could also when we start to get very clever about predictive analytics, put next month's budget in and next month's forecast. So here we're saying, in terms of leads, this is where we are at the moment, but next month we have to hit this budget, but our current forecast is here. So that's why that's red. So that this, I hope, is an intuitive journey. I'm not suggesting that if I showed you this picture right off the bat without some explanation, I'm not suggesting that you would necessarily, intuit it. Intuit it, is that a verb? Uh, but the whole point of adaptive cognitive fit, I think, is can the visuals take you on a journey? So can you build your understanding, from that simple approach, which I think is pretty clear, to, well, this is what we need to hit next month, and this is what we're currently forecasting we will do. I think that's a story. Okay. Now, between the states of leads, opportunity, etc., we have the idea of conversion. So we're looking to convert total addressable market into leads and into opportunities, sales, etc. And those could be shown at different sizes because of different conversion rates. The conversion rate here could be 20%, 10%, 5%, that sort of thing. You could also overlay the same kind of approach of, is it better or worse than you were thinking? So in this case, the budget was whatever. Again, you could number this with a hover over or something. I'm just trying to keep it simple. But here we're doing worse than budget. Here we're doing better than budget, etc. So that would direct you to where your conversion problems are. You could also, this is where it starts to get into some, sophisticated opportunities, that something like a conversion could be driven by a causal model, that not only are there data attributes that are related to the conversion, like the number of calls, the number of emails, the number of times the customer responds, the number of times the customer visits the website or goes to the academy, or whatever the interaction model is. Then if you capture data on those things, you can not just analyze from a regression point of view to say, we think the following attributes influence the conversion. You can start to model from a causal point of view to say, these attributes are linked in the following way. And then you could analyze that again by conditional formatting. So say that you made fewer calls than you thought, but your engagement was better, your lead scores were better, but your evaluations, whatever, were worse, and overall your conversion was worse than worse than you thought. So, that to me, the idea of causal modeling and understanding what the contributory factors are and how you're performing on those contributory factors is a really powerful thing. It also identifies something which is not shown here, which is confounding factors. So the idea that actually your causal model doesn't explain the outcomes, and therefore there must be some confounding factors, some data, some attribute you're missing. So I think that's very powerful. Okay, so going further, we talked about how you've performed against last period, but of course that involves people moving from one state to another. So you have people moving from total addressable market into leads, from leads into, sorry, let's do it one at a time, leads into opportunities, opportunities, sales, etc. So you can put arrows in to indicate the size of these things, and then you're losing from each stage. So, you're losing leads, you're losing opportunities. And you then also could do the same kind of thing with conditional formatting. You could say these things were higher or lower than you thought. So this red arrow here could be the subject of a drill through or a hover over or something to say, what is it that made my lead to opportunity conversion less than I thought? What is this huge loss from sales, etc.? That's the sort of analysis that could be driven by this kind of visualization. You could go mad by saying, well, actually, things move in any one period across different uh, stages. So from total addressable market to still into opportunities. I think I'd be nervous about making this diagram too busy, but time will tell. As I said, you could hover over with customer analysis. So in this case, these customers were in the forecast, but not in the actual, and these are in the actual, not in the forecast. So reconciliation between what you thought and the fact that you're doing all of this at customer level is incredibly powerful. If you're making individual forecasts about whether a customer will churn or whether a customer will move from one stage to another, then that gives you a fantastic basis of analysis as to why this didn't happen. The data suggested that this person was ripe for conversion to sale, whatever, or the data suggests actually this person's going to churn and the actual suggests not. So what's changed? And that's where this kind of analysis is called a confusion matrix, which is predicting how many customers you will retain in predictive terms and how many actually churned. So in this case, what we're saying, out of 100 customers, we predicted that we would retain 87 and 13 would churn. That was in the start of the month. So let's say the 1st of February, looking forward to the end of February, how many people do we think, because of their behavior, because of their status, customer service, etc., we think are going to churn? And then you get your actual, which says that actually we retained 88 and 12 churned, but it's split in this way that true positives, we predicted 84 would be retained and they were, but we predicted 3 that would be retained and in fact they've churned. So, why is that? What can we learn? And similarly, we predicted 9 would churn and they did. That's a true negative, but 4 we thought would churn and were retained. So that's a very simple bit of analysis that allows you to understand what you predicted and what actually happened. Okay, to implement this, as I've said, you can use AI at any stage. What I've done here is just said, generate the simplest possible D3JS. D3JS is the visualization tool that I've mentioned. To visualize the image I've given you, I have a toggle between units and value. So if I hit the units button, it turns the bars green. And if I hit the value, it turns them back blue. So the picture I posted in is that simple picture. If I go back all the way, take all the arrows off, that simple picture there is what I posted in just to get it started. Or if I go through here, and then it generated me this code. And if I run that code, I get this. So this is just running in a browser, but you could very easily put this into your visualization, your Power BI or something like that, and it toggles between units and value. So that is a way of going from a simple diagram with plain English to a working visualization. Now, obviously, that's simply Basecamp. You would then start to overlay extra nuances, extra features to say, great, that works, but can you do this? Can you put a hover over? Can you put a drill through? Can you, toggle between this and that, etc., etc.? And it will iterate through to add these features. Now, that is, I think, a very powerful tool to help you with this kind of prototyping, this kind of experiment. It might be that once you are happy that you've got as far as you can, then you would probably hand that code over to a developer to say, could you make this code more efficient, more secure, optimize the performance, optimize the data model, etc., etc., etc. But you've certainly, in a very agile way, got to something that works quickly and you can use for a demonstration, and it's the work of a few minutes rather than hours, weeks, months. Right. I hope that was useful. Any questions, let me know. Thanks very much indeed.